This wall is tasked with holding back a massive volume of water large enough to cover the entire area of the city of London. That is exactly the mega project currently being constructed by the poorest nation in Central Asia. This is the Rogun Dam in Tajikistan. When the final stone is laid, this structure will stand 335 m tall, surpassing the Eiffel Tower and beating out every other dam in existence. The reservoir capacity alone is staggering, holding enough water to fill 5 million Olympic-sized swimming pools. The driving force behind this colossal project is President Emomali Rahman. Now he is betting his entire legacy on the most difficult construction record to date, a massive gamble to turn this nation into an independent energy hub. And the schedule is extremely aggressive. By August 2025, the dam's crest will reach an elevation of 1,110 meters above sea level. This level is already higher than the future Jeddah Tower, while the main dam body is expected to be completed by 2029. Due to the colossal volume of the project, we won't see it fully filled with water until 2036. But this video is not about the politics of water. We are here to dissect the engineering. We're going to look at how engineers handle flood energy reaching 3,500 cubic meters/s, how they build on a foundation made of salt, and how they construct an earth and rock wall in an area prone to magnitude 9 earthquakes. If you love mega projects like this, please like and subscribe to the channel now so you don't miss upcoming content. The biggest hurdles here are geotechnical constraints. Practically speaking, the ground here poses a direct threat to destroy the dam structure. First, let's talk about the earthquake risk. When you look at skyscrapers in places like Tokyo, they use base isolation technology. Essentially, this technology separates the building from the ground so it can slide and dampen during seismic shaking. But there is a contradictory reality. You cannot isolate a dam. It must be firmly anchored to the earth to hold back the river. If you built a rigid concrete arch dam here like the Hoover Dam, the massive shear forces from an earthquake would snap it immediately. The chosen solution is the Earth-Core Rockfill Dam, or ECRD. It acts as a massive shock absorption system. It is a flexible structure that utilizes the principle of plastic deformation, meaning the dam body can compress and shift slightly without fracturing. They are also reinforcing the foundation to prevent liquefaction, ensuring the subsoil doesn't turn into sinking mud when the shaking occurs. But besides the clearly recognizable earthquake risk, there is another serious danger lying deep beneath the foundation, the salt layer. The dam sits directly on top of the massive Ionakhsh salt layer. The danger lies in a basic physics principle. If high-pressure water from the reservoir seeps down, it will dissolve that salt layer. That process creates underground caverns and would eventually cause the dam to collapse from below. To prevent this, engineers are constructing an extremely critical component called a Grout Curtain. They have to drill over 100 m deep into the bedrock and inject cement under high pressure. They aren't just building a wall upwards. They are forcing a permanent watertight shield down into the earth to protect that salt layer at all costs. Fixing the foundation was just the first step. The next challenge belongs to logistics. How do you excavate and relocate a colossal volume of earth and rock to build the dam body? We are talking about a total fill volume of 76 million cub meters of earth and rock.